So, new thing, they want us working out primary trigonometric ratios, meaning sine, cosine, and tangent. If you've learned SOHCAHTOA, that works perfectly fine for figuring these out. It tells us that if you're doing sine, theta, that means think of yourself as standing right down here. That is your position. And the sine ratio is the side that you see as your opposite over the hypotenuse. That's what O and H is. It's opposite over hypotenuse. The opposite side, as far as this stick person is concerned, is Y. And the hypotenuse is what we call R for radius. The idea is that you're inside a unit circle here, so the circle is all around you, and the length of these lines is always the radius of that circle. If you're talking about cosine, you're still standing here, but now they have cosine is A over H, meaning it's the adjacent side over the hypotenuse. The side adjacent to this stick person is X. The hypotenuse is still R. And for tangent, OA tells us tan is opposite over adjacent. So from our stick person, the opposite side is Y, and the adjacent side is X. Now, what these mean, we've just covered everything that this question is genuinely asking. I'm going to say a bunch more about the trig relations that you don't necessarily need to know, but you might find it interesting. If you're on the unit circle, then R is 1, meaning in this expression you can pretty well forget it's there. Sine is telling you your Y position on the unit circle. It tells you if you're over here at 0 degrees on the unit circle, and then you start going around the circle this way, with your angle increasing, your Y position goes up quickly, up slowly, it peaks at 1, it drops gradually, it drops quickly, it comes back down to 0. If you plot that, you get a shape like this. Right? Up fast, up slow, peaks at 1, down slow, back down to 0. When you get to 180 degrees over here on the circle, you're back down at 0. Then your Y position continues to drop fast, then it drops slowly. It bottoms out at -1. It rises slowly at first, then more quickly, until you're back at 0. And so you get a shape like this. This shape is called a sine wave or a sinusoid. And it's all about your Y position. That's what this is telling you. It tells you the sine function says, tell me what angle you're at, and I'll tell you where you are vertically. Cosine does something similar, but it doesn't care about Y. It's all about X. Again, the radius is 1, right? So you can pretty well ignore that. Cosine just looks at your left-right position and says you start out all the way to the right at +1. Then you move to the left, gradually at first, then more quickly. You go through 0. You continue into the negatives, quickly at first, then slowly. Eventually you get all the way to the left where you're at -1. Then you start coming back to the right, gradually, then more quickly, until you hit 0. And you keep coming to the right, quickly, then more slowly, until you reach a limit of +1. So, as you go around a circle, sine says, tell me your angle and I'll tell you where you are vertically. Cosine says, tell me your angle and I'll tell you where you are horizontally. Tangent is a combination of the two. Y over X. Does that remind you of anything? Think of line equations. This is a little bit like rise over run, which is what we know as slope. The tangent curve, if you graph it, has funny behavior. It goes like this, and then it goes like this, and then it goes like this. It keeps repeating that kind of shape over and over again. What this is telling you is, if you start at 0 degrees, the slope of this line, just a minute, I can draw a line better than that. Right. So here's your line. At 0 degrees, the slope of that line is 0. The slope increases more, 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 more. At 45 degrees, your slope is 1. Bigger, bigger, bigger. Your slope is going like 2, 5, 10, 100, a million at this point. At 90 degrees, your slope is either it's undefined or we can fudge a little bit and say your slope is infinity. That's exactly what this curve is trying to tell us. It goes up, 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 up. It hits 1 at 45 degrees. It continues to increase, and then it becomes undefined right at 90 degrees. Then it kicks in again, very big and negative. That's when your line is right here. A line like this has a slope of maybe minus 100 million or something. And then the slope goes smaller, minus 100, minus 10, minus 2, minus 1, minus 3/4, minus a half, minus a quarter, minus a tenth, until you get back to 0, which is what this part of the curve is saying. And so on as you keep going around the circle. The slopes become positive again when you have a line over here, and they become bigger and bigger and positive until, again, here your line is vertical and the slope is undefined. So, vertical position, horizontal position, and slope. Each of these has a very definite physical meaning when you're talking about lines in a circle. In physics and in engineering, we use these functions to, if we only know the angle something is at, we can figure out its position. That's a very big deal if you're designing a car engine or something like that that has rotating pieces. Figure out what angle that piece is at, and you can figure out how high is it, how far to the side is it, and what slope is it at.